per dirvi che marchiamo in faccia, ma è più sicuro.
So let's start with the second session of today. Welcome to everyone. This session is dedicated to Earth observation technologies for viticulture. So, okay. So the agenda of today is general overview about Earth observation for agriculture, and then I will introduce you the main protagonist of this presentation, that is vitiGEO's project. Is a project aimed to develop a platform for wine growers. So we will see some of the services, of the intelligence services of vitiGEOs that use Earth observation. Then I will show you the platform in action, and then we will have a plenary session to discuss about some of the topics that we prepared. I will ask you to raise your hand at any time to ask questions, and also for the online audience, write your question on the Zoom chat, and we will have Andrea that ping us with the question. So the speaker of today is myself, Federico Oldani, an AI applied researcher at Links Foundation. I already introduced myself before, but for those that were not here, Links Foundation is a private research center in Turin. Tommaso, that is a colleague of mine at Links Foundation. And then we have three speakers online that are Ernesto Bastidas, the project manager at ELIF, a private company that focused on the development of platform for agriculture. Rosa Araujo, the project coordinator of vitiGEOs at EuroGEO, a research center in Catalonia, and Andrea Nicodemu from Barcelona Supercomputing Center that will act as online moderators. So let's start now. I give immediately the floor to Ernesto to speak about his experience in Earth observation in agricultural sector. Please, Ernesto.
Good morning, everyone, and thank you, Federico, for the introduction. I am Ernesto Bastidas. I am the business lead agri at ELIF. And before I start, I want to say something about ELIF. ELIF is a Dutch remote sensing company that provides satellite-based data and services for agriculture, water management, and to assess climate risk. Federico, I cannot see the slides. Okay, can you go what? Yeah, thank you. So before going into the matter, I want to first highlight why Earth observation is important for agriculture. And as you see, we have an increasing population. We expect that by 2050, we will reach 25 billion people, and that deserves like 60 gigacalories. And the only way to reach that level is to improve land productivity. That means kilograms of dry biomass produced per hectare, and improves the water productivity, which is kilograms of biomass produced for cubic meter of water use. With that, next please. We going back one, please. Yeah, with that, also we have the European deal, which aims at basically it was approved in 2020, and I cannot, can you highlight, because I cannot see the slide, just a second. Let me see, because I cannot visualize, just let me, it's at my end, just a second. I need to visualize this.
Do you need something from here?
No, it's the thing is that it's not very visible. I don't know for the rest of the people watching this presentation online if they can see.
Yes, I just wrote that, yeah, we can see you in the big screen, but we cannot see the slides.
Yes, so.
But there was a second in which it was good. Then I don't know what you did or what other person did.
If you can.
Now it's good. Now
Oh,
it's
okay.
better.
Yeah.
Okay, perfect.
So then we have also the European Green Deal, which, thank you, Federico, which was approved in 2020. And it's basically was approved to a policy in order to transform the European Union into a modern, resource efficient and competitive economy, ensuring no net emissions of greenhouses by 2050, economic growth decoupled from resource use, and no person and no place left behind. With this, the European Union wants to ensure food security in the face of climate change and biodiversity loss, reduce the environmental and climate footprint of EU food systems, and strengthen the EU food system's resilience. And this in order to lead a global transition towards competitive sustainability from farm to fork. And this, on top of that, please next. We have the Sustainable Development Goals, which are familiar to many of us, and I have singled out where Earth observations can play an important role. And these are in the second, third, 6, 11, 13, 14, and 15 sustainable goals. So please next. So global challenges need global solutions, and that is why Earth observations can play an important role. You see here, for example, the dynamic of air temperature at 2 meters of ERA 5, where you can see how the air temperature behaves throughout a growing cycle. And that is the kind of solutions that Earth observation can facilitate. Next, please. In the practice, one.
Okay.
One back, please. I think that's it.
Oh, it's I think it's a remote control has some problem. Can you please go back to, yes, this.
Yeah, that one.
Okay.
So in that order of ideas, there have been many initiatives, for example, to monitor and stop deforestation. For example, this is a party that provides tree cover loss during the growing season of any country of any county in the world. Next, please. At eLeaf, we are working towards reducing carbon emissions, for example, by monitoring change in biomass productions, land use change detection, the consumption or use of agricultural inputs like fertilizer, chemicals, or water, and working towards the decarbonization of the supply chain. This is, for example, one of our work there. We assess the biomass production in 2 different moments in time, where you see the loss and improvement of biomass production in the Nile Delta of different production systems. Next, please. But in order to facilitate this process, Earth observation can use raw data, but also can combine different sources of data, and that is what we do at eLeaf. We combine satellite data with meteorological data and static inputs like physical variables of crop model parameters in order to calculate quantitative information. For example, the kilograms of dry biomass produced every day, or the millimeters of water evapotranspirated every day. With that information, next please, we have our 2 flagship components, which is water consumption, which is the actual evapotranspiration in millimeters per day, and plant biomass production, kilograms per hectare per day. We have this at different scales of analysis from continental, national, regional, and field level. And I must say that we will go global. After this slide, we will start providing global data for the FAO and on different variables. So it's available to anyone, but I'm going to introduce that in the next slide. So here we provide different spatial resolutions, and with this information, we can do different types of analysis, which I'm going to introduce you shortly. Next, please. One back, please. Yeah, thank you.
It's the remote. Can you go no to the next? Okay.
So, for example, we are proudly honored, and we are honored to provide data for the water productivity open access portal of the FAO. And here we provide free data accessible to anyone. These are 10 satellite-based data components at 250, 100, and 30-meter resolutions. And I update the slides in the weekend, but unfortunately it was not passed by because I got notified that we will go global. And that means that we will provide information for the entire world for this type of variables and are accessible to anyone. So please, this is going to be available. The launch is going to be on the 4th of October, and it will be available for everyone in the world. Next, please. When we look at the field information, now zooming in at field variability, we use, eLeaf is using satellite data of satellite-derived products, we call, for example, our biomass, in order to estimate better distribution of chemical applications. For example, usually chemical applications are defined by a rule of thumb, and with our data, we can provide a more localized amount of doses per pixel of 10 by 10 meters. Next, please. Also, we have been working, I mean, you have heard in the news last year, the prices of nitrogen, especially urea. We have using also our data in order to optimize the use of fertilizer. So usually these 33 hectares will consume 359 kilograms per hectare of urea, but we have been able to use our biomass to strategically localize what are the amounts of urea that that particular field will need for the coming season. And this will work in 2 ways: reduce first the price of the cost of fertilizer at field level, but also reduce the pressure of greenhouse gases to be released into the atmosphere, because less fertilizer is going to be used. Next, please. But Earth observation can be used also to generate communities. And this is how I call a community of Fruit Look in South Africa, where the Western Cape government we have been providing data to the Western Cape government through the Fruit Look platform, where it combines different first satellite data, value-added partners, local value-added partners that build on our data and help farmers in South Africa to save water, improve yield, and save money. Please, next. Currently, we are monitoring around 30 million hectares where we have more than 650 users, and this is the 12th season that we have been monitoring those fields with our information. Some testimonials says remark that that end users have been able to reduce 10% and 20%, so 19% of the users saw a reduction up to 20% of water that is being used for irrigation. On the other hand, some users have been their yields increased by 30%. Next, please. So with this knowledge beforehand and this idea, we embark to work with different partners in order to build decision support tools for the wine industry of Europe. And this is what viticulture is about. And my colleague is going to introduce you shortly. Thank you very much.
Thank you, Ernesto. Thank you for your intervention. I think it's good to know your experience, ELIF experience, a real use case scenario in which you use Earth observation that, as you mentioned, a global problem require global solution, and Earth observation is actually a global solution, can drive to a global solution. So thank you for your introduction. Now I leave the floor to Rosa Araujo for a brief introduction of the viticulture project. So go ahead, Rosa.
Well, I think that first we have this nice video to show, no, at the very beginning.
Okay.
Is embedded into the presentation.
I don't see. Can you show me the? Okay. Do we have the audio?
Okay. If there's a problem, no problem, because this video is also uploaded.
The European Union is the largest wine-producing region in the world, with over 165 million hectoliters produced annually. Climate change, provoking a higher frequency and intensity of extreme weather events, threatens crops all around the world. On the other hand, more than 20% of greenhouse gas emissions worldwide come from agricultural activities. This demonstrates why today, sustainable agriculture is more important than ever. The European-funded project viticulture contributes to the increase of sustainability in the wine industry by offering a platform for optimizing day-to-day field management. Based on the integration of Earth observations, combining satellite data and sensors in the field, the viticulture platform offers services providing advanced weather and sub-seasonal and seasonal climate forecasts, crop status indicators, phenological monitoring, disease warnings, crop water demand requirements, and a tool for managing business operations and sustainability assessment. viticulture aims to deliver a reliable decision support system to winemakers for smart vineyard management, supporting sustainable grapevine cultivation at an economic, environmental, and local level. The platform, being co-developed and tested in vineyards of 3 European wine producers, boosts vineyard sustainability and eases the industry adaptation to climate change. viticulture, striving for more sustainable vineyards and winemaking. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 869565.
Okay, thank you very much. Good morning, everyone. It's a pleasure to participate in this event, and I'm very sorry for not being able to be physically there. I'm Rosa Araujo, project manager at EuroGEO Technology Center in Spain, and the coordinator of this very, very nice project. Here, well, I cannot see the slides. I see them very small. Now, perfect, thank you. Here, what motivated the project? As we've seen also in the video, as tangible data, we have that Europe is the biggest wine producer in the world. 60% of wine production comes from Europe, and agriculture is a major economic activity in the south of Europe. 20% of the total jobs in agriculture are related to wine, representing around 3 million jobs. As we know also, agriculture has a very important role in climate change, being responsible for more than 20% of CO2 emissions. And on the other side, conventional agriculture is currently facing new challenges, for example, reducing dependence on pesticides, improving biodiversity, or adapting to climate change. If we want to help sustainable agriculture, not only new practices and tools are required to meet the needs of people and take care of their health, but also additional solutions to contribute to reduce the negative effects of the climate change. Next slide, please. What is viticulture? Viticulture is a Horizon 2020 project, an innovation action funded under the call SC516 2019 for the development of commercial activities and services using GEOs and Copernicus data. Its duration was planned over 42 months. It started in September 2020 and it will finish in February 2024. This means that now we have 4 months left, and during this last phase, we are validating the results with the third vegetative season. Next, please. Thank you. viticulture consortium is composed of 9 partners from 4 European countries, and all members join the necessary expertise and operational capacity to implement all the project challenges. As technical partners, we are EuroGEO, Barcelona Supercomputing Center, ELIF, LINX, and Università di Napoli, ensuring the high innovation capacity of our technologies. From the end user side, and validating the services in real settings and providing the data, we count on very big wine producers, as they are Mastro Bernardino in Italy, Symington in Portugal, and Torres in Spain, ensuring a real orientation towards the business exploitation. PricewaterhouseCoopers, leading the commercial activities for a successful market penetration also. Next, thank you. Then, what is viticulture concept? It is an ecosystem of services to optimize sustainable wine management with decision support systems on phenology, irrigation, disease, and business operation. It provides support to the wine growers in the management process by means of different technologies such as satellite imagery, drones, in-field cameras, and sensors, and all them integrated in a set of intelligent services. Next, please. At the end, what viticulture wants is to support smart agriculture to achieve 3 main outcomes: increase productivity, enhance resilience, and reduce emissions. The platform combines Earth observation, data, and services, very relevant for the wine industry, and in particular, optimizing decision maker for better control and monitoring, allowing wine producers make informed decisions, for example, on the seasonal and subseasonal temporal scales, helping to be prepared for extreme climate conditions that can damage the crops. Also, recommendations for improving the use of resources and efficiency to schedule the management tasks according to the available resources in a way that minimizing its cost, and in terms of time, economic or environmental costs, which this can be prioritized by the farmer. Also providing real-time information in a single platform, combining multiple data sources, satellite images, in-field weather stations, and weather forecasts for ensuring better accuracy of the predictions and helping to implement specific measures by knowing in advance, for example, the date of each of the phenological phases. And finally, also providing predictions to anticipate and face main risks due to climate change. We know that climate change is a serious threat to agriculture because it's reducing crop yields, lowering productivity, and increasing the risks of drought, diseases, and extreme weather events. And also, we've seen that, unfortunately, these impacts are expected to worsen as the global temperature rises and the weather patterns become more and more irregular. Thank you very much, Federico. The audience.
Thank you, Rosa, for the big picture around viticulture. Now let's continue with the description of some of the services in viticulture that use Earth observation. So for viticulture, we developed different intelligence services, but some of them are specific using Earth observation data. Basically, we use Earth observation for identify management zone, detect anomalies, highlight stressed area, but also to monitor the phenology, for example, and perform some area inspection. Now we'll dive into the first service, that is crop status indicators, that exploit all the Copernicus constellation to provide information about NDVI and leaf area index, obviously, but also evapotranspiration, biomass production, nitrogen content, that are all indicators that outline, highlight the status of the vineyard. So it's important for wine growers to continuously monitoring these parameters of the vineyard. And it's not always possible for wine growers that have many hectares of vineyard to understand all at once the status of their properties. So this crop status indicator aims for this scope. The second intelligence service that I want to show you is the phenological monitoring. For those that are not expert in phenological monitoring, phenology is basically track the crucial stage of the grape wine during the season, the vegetative season. So it track all the stages from bud break to berry maturity to the ripening. This is very important for the wine growers. Because at every stage, the wine growers needs to take a different action, and they need to know the status, the phenological status of the vineyard at any stage, at any time. So I will show you how we use Sentinel-3 to monitor this type of information. This module that we developed include several data sources. We developed a module that is called Pheno AI because it uses different models, different artificial intelligence model to monitor and forecast the phenology. The different models is because we use different data sources. So we develop models that use, for example, Sentinel-3 or weather station data to monitor, or camera images to monitor the phenology, and we use climate, weather, and climate prediction to forecast the phenology. Why we have so many models to monitor and forecast phenology? This is because of sustainability of these services. We thought about having different models that use different data sources to have to ensure a scalable service. So because we know that not in every vineyard we have weather station, in-field weather station. Okay, so if we cannot have weather station, we can achieve the phenological monitoring through Sentinel-3, for example. And now we will see the Sentinel-3 approach. Basically, Sentinel-3 offers 3 bands, 7, 8, and 9, with 2 measurements per day about the land surface temperature. So we can measure the temperature of the land twice a day, with a spatial resolution of 1 kilometer square. Although the spatial resolution is very coarse, we believe that these measurements are enough to outline the behavior of the temperature of the land in the vineyard. So in this chart is shown the weather station, the temperature measured with a weather station in orange, and the temperature measured by Sentinel-3 in blue. As we can see, the behavior is similar, so we believe that we can approximate the weather station temperature with Sentinel-3. And here, our approach, we processed the time series of the land surface temperature, with in addition some basic information about the vineyard. And we process this information with a recurrent neural network to outline the behavior of phenology through the year. As a result, we got a pretty good result, especially in comparison with the baseline that we use, that we considered, that is growing degree days. That is a standard ways, traditional ways to monitor phenology. So with this technology, we can achieve more or less 7-8 days of error in phenology monitoring. And now this was the phenology monitoring service. And now, Tommaso, we will present you the drone analysis service.
Thank you, Federico. Within the viticulture project, we also introduced a remote sensing vineyard monitoring service, which leverages drone acquisitions. The main advantage of using drones for applications of smart agriculture and viticulture in particular is the higher resolution that drone cameras have in comparison to, for example, other data sources, for example, satellites. This higher resolution enables new tasks to be performed. And for example, in our case, the task was a semantic segmentation of vineyard rows in vineyard imagery. And this was done using a deep learning model. And the downstream application of this is the computation of 2 new vegetation indexes, which are the vineyard density index, which we introduced, and the visible NDY, which is basically a proxy measure for the NDY, which is originally a multispectral index. The VNDY is based only on RGB images. So we basically acquired over the years of the project several drone acquisitions of vineyards of the involved wine growers in the project. With this data, we developed a semantic segmentation model that could perform the segmentation of the single vineyard rows in the vineyard. And as I was saying, we were able to compute these indexes. The critical point is that, for example, the VNDY analysis that we have performed could be performed separately on the rows of the vineyard and the inter-row area. And this is not possible when using satellite data. And for example, the NDY index, which is computed based on Sentinel-2 acquisitions. For example, here, the rows of VNDY and the inter-rows VNDY gather two different information. For example, the VNDY computed on the rows is important and useful to estimate and to assess the general state of health of the single rows and the general vigor level of the rows. Whereas the VNDY computed in the inter-row area is also useful because we can, at the first glance, see if there is any ground cover vegetation. And ground cover vegetation, such as grass and bushes, is often unwanted by wine growers because it actively competes with the search for nutrients in the ground. The other index is the vineyard density index, which basically estimates not only the number of rows in a certain area of the vineyard, but also the thickness of the rows. And this is another measure which is useful to assess the general state of health of the vineyard. Okay. So this concludes our presentation on the delivered projects of the delivered services within the viticulture project. We will be happy to receive questions if you have any. If not, we can go on with the presentation. Okay. So our commitment to the viticulture project yielded not only useful services for the wine growers, but has also delivered to us useful insights and lessons learned in the domain of earth observation applied to smart agriculture and viticulture in particular. A first lesson learned is that remote sensing and satellite data in particular can be the best option to monitor a vineyard, but only in some particular cases. Proximal sensing techniques like in-field sensors have the advantage of being accurate in their measurements and can also take frequent measurements. And this leads obviously to very accurate models. For example, the phenological model that Federico talked about. But one of the cons is that in-field sensors can be very expensive because they must be scattered all around the vineyard to acquire meaningful data. And they are often prone to failure and require frequent maintenance. On the other hand, satellite data is easily scalable because one single acquisition of a satellite can cover not only the vineyard, not only a single vineyard, but most of the times the whole estate of the wine grower. And most of all, they are freely available, at least in the case of Sentinel satellites. Obviously, the con is that it has lower revisit times, so we cannot have hourly measurements like we did with the in-field sensors. And it has a lower resolution. And this leads to less accurate models, for example, in the case of the phenological model. Nonetheless, we argue that satellites are the best tool to monitor vineyards which are very large in extension. They may be maybe the only tool to do this kind of analysis and monitoring, whereas in-field sensors could be used also in small to medium-sized vineyards, because it will be feasible to do so in that case. We saw that satellites are good to monitor a vineyard and to estimate some biophysical quantities, some crop indicators. And for example, let's take this case study here. This is a graph which shows the evolution over the year of the NDY index as computed by the Sentinel-2 satellite. And we can see that the progression of the NDY index is basically logical, because we see that this evolution has a minimum in the winter, and when the grapevines are basically dormant, there are no leaves. And there is a peak, there is a maximum in late summer, maybe early fall, when the vineyard is ready for harvesting. And this is something that we expect in general. This is the same graph, but for another vineyard involved in this study, in this project. And here we see a counterintuitive behavior of the NDY index. We see that the maximum, the peak, is in the winter, whereas there is a minimum in the summer. This is easily explained if we take a look at some in-field acquisitions by a camera. In that particular vineyard, we can see that in the winter there was a lot of grass and basically no leaves. The grapevines were basically completely naked. But the satellite is correctly looking to a fully vegetated field, basically because there is grass all over the ground. And so it returns a high level of the NDY. As the year progresses, the grass disappears and the leaves start to appear on the plants. And obviously the peak is in July and August. But the NDY is still lower than in January, and that's because the vines are not closed in canopy, and this means that a satellite will see that there are holes between the rows. There are inter-row areas which are basically naked soil. It's bare soil. So the NDY index will be not very low, obviously, but still lower than in the winter. And this is because of the low resolution of satellite data. And as we explained, in this, let's say, pathological case in which there is grass even in the winter, it may be useful to support satellite data with the other kinds of data sources especially the one we talked about, drone acquisitions, because of their higher resolution. For example, a typical drone will fly over a vineyard and acquire images which are 1 to 10 centimeters per pixel in resolution. And this enables us to perform an analysis which is more fine-grained, also in relation to the NDY index. And now I will leave the floor again to Federico for the last lesson learned.
Thank you, Tommy. So the last key takeaway of vitigeos is something that maybe we cover a little bit in the previous session. That is, sometimes from satellite, we have lots of data. But we are data scientists, so we can understand this data. The problem is that for the wine growers, not always the wine growers are interested in seeing every number behind the satellite data. So our takeaway here is to simplify as much as possible the data visualization for wine growers, and maybe offer different level of detail for the wine growers. So it's important that they have at a first glance a picture of the vineyard, seeing which data, which areas is suffering, which area is growing well, and if he or she wants, he can go in detail and see other numbers, other information. So, for example, this is an example of how we visualize in the platform the data. This is the evapotranspiration index, but instead of seeing the numbers of the evapotranspiration, we see just how is going the evapotranspiration in the vineyard, below in average, below average, or above average. So this is kind of information that can give a big picture, an immediate picture of the vineyard. So these are the 3 lessons learned of vitigeos. Do you have any question, any curiosity about this? Oh, yes.
Thanks. My question is, what was the response from the industry partners to the data you provided? Because I mean, from the data scientist point of view, it's great, but I was wondering, how actionable it is for them from in their daily activities.
Which service?
I mean, you're providing a range of services, and you described those one in terms of the, I think mostly health or the growth period. Could that information be used by the, the vineyards themselves? Or did they provide any feedback to you in terms of, what was the day-to-day activity potential?
Yeah, exactly. Well, it depends on the service, but for example, I can talk about phenology. Phenology monitoring is something that wine growers still today perform manual observation to get information from the vineyard. This is extremely important. But in case of extremely large company that have maybe vineyard also with slopes, it's not always possible to go around the vineyard and see the actual status of phenology, and this is why we implement the phenology monitoring. For the I must say that today the model is just an advice is just it gives an idea of the phenology state. But we have another part of the service that is phenological forecast, for example. This is extremely important and is used by wine growers, for example, to for example, the first phenological stage is the bud break. At the beginning of the bud break, wine growers need to start the insurance. So they really need to know at which day the insurance is a little bit expensive. So they really want to know the exact date at which start the insurance, or at which day they need to be prepared for the ripening, for the ripening. So it's for the phenology, it's very important to collect this information, to give this information to the wine growers. For the drone service, it could be used. We don't have actually we don't have any direct experience because it's the first year today. This vegetative season is the first season in which we provide the outcome of the drone service. So it's under experiment, let's say. But it gives a specific idea to the wine growers to precise information about which area is suffering and the reason, because sometimes from satellites it seems that all is going well, but if you see the drone images, you see, for example, that there's just grass in that part of vineyard.
Thank you. This links in well. I've got some drone questions for you. Have you ever thought of adding a thermal camera to your current sensors?
Can you repeat?
Have you thought about thermal imaging, because you've got RGB at the moment?
Which sensor? Sorry, I cannot.
A drone.
Chemical.
To your drones.
Thermical.
To your
Okay.
drones.
For which service? I mean, the Sentinel-3 offer terms. Do you mean for drone service?
Yes.
Okay.
So attaching a thermal camera to your drone,
Okay.
or actually expanding what. So
Okay,
which
if
drone
you wanna...
do you use for capturing this, and what software do you use to process it? Do you export it from the drone software, or do you put it into your own?
Okay, tell me. You
The main reason we didn't use the thermal cameras is that the wine growers that were involved in this project did only use RGB cameras, at least 2 of them, because one of them uses a drone with a RGB camera and a thermal camera. But we wanted to create a service which could work for everybody, even with a cheap, let's say a cheap RGB camera installed on a drone. And so we did not experiment very much with the thermal data that we gathered from this one of the 3 wine growers. It is basically, for us, it's future work, basically. The main advantage of using only RGB cameras, and so of using only vegetation indexes which are based only on RGB data is, as I said, because, is that RGB drones are cheaper and they are easier for wine growers to buy and to use. And also because there are already works exploiting thermal plus RGB data. And we wanted to create some service which only exploited the RGB data, and because that was a new frontier in for this kind of application for semantic segmentation of vineyard rows.
Okay, thank you.
Thank you. As you mentioned, some curiosity question. I have one regarding, so you mentioned you were a data scientist, and you mentioned some type of data, including in situ measurement. I would be interested in maybe later knowing about what type of sensor do you get and what type of measurement did you collect, just for the sake of my understanding. And you mentioned as well drone. To that respect, regarding the fact that you align with GEOS and GEO, and as well funded by the European Commission, did you conduct any concrete activity regarding data sharing? And how basically did you collect those data, and especially in situ measurement and drones? So we know about EO data, which are already collected and cataloged. But regarding this topic, did you conduct any practical data sharing exercise just to basically be in position to share those data to the community at a larger extent?
Yeah, I agree. And data sharing is one of the main topic of the previous discussion, and it could be very useful at this stage to have a big data hub for agricultural data. The fact is, in viticulture, wine growers not always share easily their data. So we have the data from 3 pilot cases around Europe, but in some cases they explicitly ask us not to share the data about phenology, for example. They don't want to share the phenology dates because it's a they want to keep them secret, private, let's say. In other cases, we can share the data. It's not actually is not on Earth observation, but for example, we had a model that used in-field cameras. In that case, they agree to share the data set. So we will publish a paper with 2 years of in-field camera images attached to the paper. That's quite new in the scene because we didn't find any data set of this kind in the web. For the drone, I don't remember if we asked the permission to publish the dataset, but maybe it could be a possibility. I don't know. I'm not sure they will agree on this.
Yeah, just a quick follow-up. Just data sharing and data management principle as a whole is wider than only having the, let's say, the right to share data. There's good practices in encoding, sharing, even among your community. So
yeah. No. I totally agree with you, and I always look for data shared in this. Here, the topic is not always the property of this data is not our property, but it's wine growers' property. So they must agree on the sharing. We are struggling to convince them to share some of the data, and this is an actual problem.
Thank you. Just a question about the drone data. So you show it like, it seems to be way more useful. I'm just curious about the cost of acquisition per square kilometer. What was your estimate? And then also how much time it takes to get it into analysis ready shape, the drone images.
Okay. I don't have the detailed data about the acquisition because we take the images. The wine growers have chosen an external company to acquire data from drones as a service. I would say that I don't have any detail about the kilometer square that we can cover, but connecting to the previous question about the thermal cameras, the problem is that we before starting these services, we ran research on the market. We have seen that there's lots of university and research center and private company that run super complex drone with thousands of sensors that give you precise information about everything. But they were extremely, I would say, out of the market because for wine growers who want to see the vineyard from an aerial inspection, and it's focused obviously on the money. And
I was just looking for some
I don't
approximate number, but you know, you pay the company.
More or less, it's the budget was 3,000 or 5,000 euro per each vegetative season to run 6 flights during the season. So this is more or less the information.
How many hectares were the?
Yeah, I need to check it. It depends on the company because we run the acquisition in 3 different European countries, and every country has its own cost.
Okay, thank you.
It was with drone with propellers. Yeah. Yeah, but I guess it's at this point the resolution would be less, isn't it? Because with these images we can reach the resolution of 10 centimeters per pixel.
But you can do that even I was flying vineyards with a drone 2014 to 16 using fixed wing, and you can cover quite a lot of area only flying at maybe 120 meters maximum because of the CAA regulations, and you'll have centimeter precision. You can download this information and put it through the software of the drone to actually produce potential NDVI. So this is why I was asking if they do it through the software provided by the drone company, or they actually export it and you can put it into ArcGIS or Esri, however you want, and deal with it like that. So there's lots of different ways to get here, but it's very important for your drone imagery to understand the platform that it's taken off and the parameters, because that will impact potentially some of the information you pass to the farmer.
Yeah, that's interesting. Maybe we can talk later about this. I'm interested in what you're saying. Okay, let's go ahead. I can show you the viticulture platform. Here it's a recorded video of just on that focus on the services that we present you today. Also, this is the link to the platform. Obviously, you need some valid credential, but if you want test the platform, just get in touch with us. At the end of the presentation, you will find the contacts. Okay, so the platform require a login. Every user have a login that allows to see its own vineyard. And here is how the platform looks like. You can have access to all the intelligence services that we developed in vitigeos, and then selecting one particular field, you can see the details of the field, and you have immediately information about the status of the vineyard. For example, as I explained before, the third lesson learned is to give at a first sight an idea about the status of the vineyard. In this case, you have different indexes, and selecting the indexes, the color changes based on the status according that particular index. And of course, there's a second level of details where you can see along through all the year, all the information, in this case, qualitative information about a particular index. So you can see how the index goes through the year. You also can a detailed view about the index, and maybe also compare the same vineyard at two different times to see which are the different, if some areas grows as expected, and the other areas that grows less. And so this is for some qualitative information, and here you can see also the evapotranspiration, for example. You have access basically to all the indexes that we provide. And then these are kind of qualitative information. And then you can have access to the quantitative information, that is the third level of details. And you can always export the data in an Excel format just to share and to use in other platforms. The second service is the phenology. Here, in this case, the phenology for that particular field present the outcome of all the models that we developed for phenology. We have two models for the detection, two models for the prediction. Obviously, in a production use case, we will have maybe just two models, one for detection and one for prediction, based on the data sources that is available. This is a research, for a research purpose, we put the outcome of all the models that we developed that use different data sources, and obviously they have different precision. And it's always possible, regarding the topic of data collection, it's always possible for the wine growers to input their achieved date of the phenology, so that we can have always a feedback and data for a reprocess later on. Now let's go to the last part of the session, that is to discuss a little bit all together about some hot topic. But before, I want to know who are you, where are you come from, and which are the roles that we have in this room. So maybe I don't know if we can pass the microphone one by one, but maybe because we already did in the last session, so maybe I just ask you how many of you are researcher? Okay, so we have lots of researchers. Okay, and how many are technology provider? Okay, interesting. And for the other, what are your role? Maybe can you present yourself?
I'm actually a lawyer, an Italian lawyer, but I specialize in the regulation of digital technologies. So I'm interested more in the legal aspects of, for example, data sharing or data governance. And I'm currently a policy advisor at the Ministry of Agriculture in the Netherlands. So actually, I was very interested about the aspects and agreements, and you said that farmers are not very willing to share their data. So this is some of the aspects that I'm interested into, and of course, all these developing regulations at the European level on Data Act, Artificial Intelligence Act, and Data Governance Act to see how this impact what it means in practice for companies and governments as well. So yeah, this is a little bit my
cool,
background.
interesting. And thank you.
Hello, good afternoon. So yes, we are technical in the afternoon. My name is Nilkumar Dev. I'm the former head of technology transfer of the Italian Space Agency. I'm now working as a space economy advisor for regional entities in Italy and abroad on policy, but also on activities to match space and non-space. And the other hat is I'm a partner of a VC fund investing in space startups and spin-offs.
Thank you. Okay, it's your turn. So I leave the word to Tommaso to lead this session.
As Federico said, we want to stimulate discussion with you and to engage you in discussing some hot topics in smart agriculture in general. And our first question to you is if you have any experience in similar technologies to the ones that we presented today. Maybe not only related to viticulture, but also to other cultivars. And in general, if you can think of other kind of plants, other cultivars that can be to which we can scale successfully this kind of technologies.
Yeah, I'm Marco Folegani from Mio. We are working on not similar, but in the same domain, since we are implementing some kind of services based on the analysis of climate indicators related to the cultivation of, for example, tomato or agrumes in some part of Italy. And yeah, from our perspective, we are working more on identification of stressors, climate stressors, in order to try to estimate a correlation with the productivity for some kind of crops. And in our case, the scope is to identify suitable area or to try to predict with the support of climate scenario those areas that could be not good in coming future for some kind of crop, or that could be good for other that not are currently cultivated.
Thank you. And some researcher, we have lots of researcher here, so maybe you have some experience beyond vineyard. I bet. Do you have any on which other cultivars do you focus your research? Don't have any, just vineyard. Okay, so this is a success story by eLeaf company. They successfully scaled their services related to the computation of crop indicators, also to other cultivars such as sugar canes, table grapes, and apples. And this lets us think that there are some characteristics that a cultivar should have in order to scale the viticulture services. And these characteristics are, for example, an extended cultivated area, because, for example, it's better to use satellites when there is a field which is very extended, because it will be infeasible to use other techniques such as sensors installed in the field, or even using drones. It is cultivars which are more suited to these services are preferably closed in canopy, and this is mostly in relation with satellite data, because as we explained before, there is a serious problem when the field is covered in grass and there is a ground cover vegetation. So closed canopy fields and plantations solve this kind of problem. So maybe this kind of plants, this kind of crops are more suited to satellite analysis. Another characteristic could be that we want to monitor crops which are highly susceptible to environmental conditions and, for example, to climate change, because then it is important for the field workers to check whether there is some stress in the plants or even some diseases. Because there are many crops which are more prone to this kind of problems. And one last characteristic could be that we can scale services to crops which require some operations to be performed during their growth based on their phenological stage. Yeah, don't know if you have any. Yeah.
So it's more general question, but I mean, if you look at wheat, for example, there's a lot of advanced wheat models already to forecast the growth and doing locally projection on when the different stages are happening and how you manage it in the field. And I guess this is really prone to using smart agriculture and the maps and the tractors to really alter the stuff. And I was wondering how much option, or have you tried to look at existing models? I know there's groups like it's called AgNIP that try to go synchronize all the different crop models across the world to improve the prediction, and how this could link with really getting in-field data and projections to get to farmers, and how much you could adapt the AI you're using, because you were mentioning how you predict the phenology is AI based. I don't know if you have also like mechanistic component behind it, or how the both intertwine.
Yeah, I think Federico will be more suited to.
Yeah, how is the model that you mentioned?
It's called AgNIP. It's a group that is they have crop models for wheat, for corn, for rice, and they try to bring them together to get something that increase the accuracy of projection. And you have different cultivars, different locations, And I think it could complement very well in having this in situ component as well, and bringing the satellite data, which I don't think they're doing. And
Yeah,
maybe
we haven't heard about it, but yeah, we can look. Thank you for your input.
Can I say something, Federico?
Yeah, Ernesto.
Yeah, no, I mean, that is quite interesting initiative indeed. And for example, what will be interesting is to see the possible partnerships with that kind of approach, where because from eLIF we have conceptualized some of the models. Of course, we cannot take into the whole spectrum of agricultural models, but for sure it will be an opportunity to interact with that kind of research groups, which have a quite more deep understanding on different commodities, to see how Earth observations can add value to the current set of variables that there have been already defined. What we have found out, because we did some work with some of those models, is the characteristics is that it's a crop that stays short in the field when we look at summer wheat, and usually it's more prone, for example, when we look from satellite data, to lodging. That is one of the components that was highlighted where to use this kind of technology. For the yield and yield forecast, then the component is to see how to reach to the first take into account the dry matter content in order to get the amount of kernel, because when we measure is the whole canopy, and then we try to infer what is going to be the amount that indeed is the harvester material. In the corn, in the wheat is only the grain. So the challenge there is to get to the grain, and also to play with the moisture content of the grain. So those are quite two interesting challenges when we look at that kind of cereals of commodities.
Yeah, thank you, Ernesto.
You're welcome.
Okay, I think I will give you the floor for. Okay, yeah, there's a last question that we want to leave you. That is. It is related to this, but what is the future? What are the other use cases that we can implement in the future? So Marco already mentioned, for example, the lens suitability to analyze the historical condition of a soil to understand which, for example, which cultivar fit the best with that particular condition. Someone from the discussion before mentioned, for example, the water management. So maybe not only the estimation of irrigation that the crops required, but also the forecast based also on the weather forecast, for example. So that's quite interesting input of this session about these other use cases. Do you have any other experience in agricultural sector to other use cases? Nobody? Yeah.
I'd maybe have a general question on that future topic. So we've heard that you have a platform set up now for viticulture, and I think you have to, I didn't understand exactly how you can access, but at least you need login and maybe be certified somehow to get there to login. Then we've heard that there are good models that tell you where to plant which crop at which times, or if with climate change we should move to potatoes or whatever. But for me, always the biggest problem is to find all these different things and to know where they are available and how to access them. The same thing with these crop models. There's certainly a homepage that is there that shows all these different crop models, but they're kind of inaccessible. And so I wanted to ask, what is your approach with the platform that you have? How open is it, or how easily accessible is it? And how easily is the data that you have in the platform, how easily is it to be shared with, let's say, other platforms or other applications? Because I think in the end, that's the most important thing that we have to solve, to get this information somehow together and make it accessible and interoperable.
Yeah, interoperable, it's the right word that we should focus. Well, the platform is an eLeaf platform. So it's their business product. So I don't know if Ernesto, you wanna answer. How is your experience in interoperability and sharing information about that is on your platform?
Thanks, Federico. First, we start from the baseline that the data needs to be private, and that means that if you are a user, you only have access to your farms. So that also adds the level of responsibility with the data management plan. On the other hand, there are options that you can share your fields with possible consultant groups. So for example, if you have a person of an entity that gives you some kind of consultancy for your fields, you can grant access to that particular set of fields. The process that the landing part of the platform and how the end user interacts with it is a process that first we do a collaborative exercise where we go with him, train them how to use the data. On the other hand, when we look at the interoperability, we have developed an API service store which allows the interaction with different partners. And this is the case in viticulture, where we have different sources of data coming from different intelligence service providers, and they are collected into one system, and the system is viticulture.
Yeah, thank you. Yes, I agree that we should focus maybe more on the data availability and data sharing more than other use cases, maybe, because yeah, it's difficult. As I said before, it's difficult to convince the wine growers and other in the agricultural sector that data sharing is also for their goodness, is also to develop something that one day they can use, and and also the interoperability between platform should be agreed together, because maybe I'm wrong, but correct me if I'm wrong. There's not a solid standard about this interoperability. I mean, there's standard for geospatial data in general that we can apply to the agricultural data, but maybe there's some missing spot for agricultural sector.
May have, yeah, maybe by design think of, it's not the case, no worries, still good things to do, but you have, whether it is processing, whether it is data encoding regarding in situ measurement. I'm not familiar with drone, but maybe the drone community has been put these things together.
The problem is maybe there's too many standards.
Okay, you're in Geo, at least I'm not advocating, I'm not from the OGC, there's no Marie-Françoise over there, so, but OGC has plenty of, you may have basically find potential support for your
yeah.
Hi, Federico. It's Andrea online. So I just wanted to say we have a question. I don't know if Jose, you want to repeat your question, or I can read out what you wrote.
Andrea, can you wait just a minute? We have a question here.
Okay, sure.
Now, I just want to link a few things together. We've got, we spoke about agriculture this morning, and something that's come out a bit with what you've been saying has been the farmers are not really willing to release their data. But can you go into a little more depth of maybe why and which particular data sets they do and don't want to do? Because we have to deal with the data spaces that are coming up in Europe, and there's an agricultural data space. So understanding, I guess, why some of the data providers can't give data is useful for our overall goals and objectives. Thank you.
Yeah, it's something that we can discuss with the wine growers. I can bring you the example of phenology, because it's something that we published about, and the problem was that the wine growers don't want to share the exact date of the phenology. Actually, I don't know about, but I don't know why, but I can guess this is because they don't want to allow other competitors to know much about the process in the particular company. So this is I can guess it's still a competitive reason. Yeah, maybe the lawyer have.
Well, no, actually, this is one of the topics that I would like as well to unpack, because I understand that as well, there is this reluctancy because it's not known how this information can be used. And of course, some ways of using may be known, others not. And so new ways that could come out and damage them may be thought about. So of course, they are trying to make sure that sharing the data then doesn't come against them. But I was wondering, this of competition is indeed a topic that I've also heard a lot about. Others could be insurance companies might use this data or information about the quality health of a field to maybe increase the prices. And so this is also something that farmers are afraid of. And then in general, the idea of monitoring can be perceived in the wrong way as a tool to immediately fine if something is not going as it is supposed to be. Then, of course, a lot of techniques are also, or let's say, there are a lot of subsidies that are given based on certain preconditions, and actually could be valuable for governments, for instance, to know what's going on, to see if subsidies, the conditions are met or not. But from a farmer perspective, this is also quite scary. So I think, but this is my personal impression, that there is a lot to do in, we discussed also this morning, communicating the goals, the purposes for using the data. But my question, well, I have few here. First of all, is if in this experiment or this pilot that you have, you had the chance to compare the decision-making process of farmers without knowing all this very detailed and fantastic information that you can provide them, and what they would have done indeed without this. So like to see if I use these technologies, I would make this decision. If I don't have this technology, I would make this other decision. Do they look alike? How better it is the decision I could make based on the technology? So this is something that I was wondering if you did any kind of experiment. And in my mind, this might be valuable to show them what they could gain from using this kind of technologies. And then another topic that is in my mind, and I understood it's also among the reasons that sometimes make farmers very doubtful about whether to use or not these technologies, it's also the accuracy. So we discussed also satellites have reach a certain level of accuracy and drones would be more accurate. Then of course this has an impact also on the quality of the data that you make available. And then who would be responsible in case of mistakes of the information that is produced? And so also this, I think it's a very important topic. I absolutely have no answer to this, but to my understanding, it is a topic of concern because then how much can we rely on this information and what happens if this information proves wrong? This is something that in my mind needs to be tackled also.
Yes, that's very good questions.
But again, it's not solutions.
But starting from the last question, something that can be done is always offer some probability of this the data that outcome from the models are correct. And in any case, the platform is still a decision support system. So the final decision, we provide information to support the decision that must be taken always from the wine growers. So at the end, is the wine growers that can exploit this information, but with its own experience, have to take the decision for the vineyard. And the other question was about the comparison maybe between the result with or without these technologies. That is the scope, the objective for this third vegetative season in viticulture is to validate our intelligence services to show the end user what are the differences between, the goodness of our services, and if they can be fine, if they can find useful using these services or not. For example, there is a service in viticulture that is the disease forecast. And we have some small areas in each vineyard in which the decision taken are based on the outcome of the disease forecast model to see which are the difference between the yield at the end of the year. We can see the difference between the yield of these small areas with respect to the other areas in the vineyard. So it's something that we are working on it.
Thank you, that it's useful. Maybe a question for you. Is there any data that you as a service provider would not like to be displayed? So one thing is, okay, I want to share the data about the plots and how they are doing and the quality of the soil and the temperature. But is there something that as a service provider you would say, well, this would say too much about my business and I do not want to share it because, you know, this is my, it's confidential, it is a trade secret. So maybe, I don't know if it's just for you or maybe for the other technology providers that are here, because this is also helpful and very often is part of the discussion, because it's not only about information about the soil, but also all the other actors that work on it.
No, as is my experience, we actually don't collect any, I mean, all the data that we collect are basically are based on Sentinel-3 that is public available. So in this case, we don't have any additional data and The only thing that we don't share is the final model, for example, for phenology, because it's our property, but we publish a paper describing all the process and all the pipeline, so it's easily replicable with the same data.
Yeah, so if I may just provide you a testimony from another sector. So I work in the renewable energy field, so mostly on solar radiation. And we are using in situ measurement coupled with, let's say, metadata with a satellite or model for decades. And we came to this basically activity of trying to convince the community that operate and maintain weather stations, so big weather station, met station. But now you have plenty of PV plants that are basically fully equipped with instrument measuring the solar radiation, the wind direction, the humidity, the temperature. And we try to engage with them to basically share your data. And we face this issue. So it's a long journey, but you have to provide a concrete example of the benefit of sharing your data, meaning that if you want to size a plant in a given area and you only rely on a station which is 200 kilometers from basically the place you are spotted, it is basically useless. So it's basically very core information. So sharing the data into a network where you basically could be providing this to the community and basically competitors as well may basically benefit and share as well data is something we've tried to basically work the concept. So we have some, let's say, success, let's say. So we have been able to share a private company type of in situ measurement that belong to their PV farm. So we have put little basically advertising. So libinsitu.org is basically a full set of best practice to encode, to share data using data management principle, data sharing principle, that as well as a network of over 300 stations, which basically we share for the community. So there you will find data which are open, data which are not, and we are struggling to make those providers open the data. So you have to provide, you have to guide, you have to educate. It's a very long story, but it's finally works at least at some extent in some activity. So I don't know about agriculture, but basically we share the same ground of going to the data provider, make them basically aware about the benefit of sharing, and then you have to guide them into sharing. Sharing is not I share. So you have plenty of things, especially if you want to be in this EO, open data, open knowledge spirit. And but there are recipes, would I say. Yeah, Mark.
Yeah, thanks. I'm Mark Noord, member of the advisory board of viticulture. And we discussed all this in the advisory board meeting, so it went along the same lines. If you look at this particular situations, these are not small companies. These are quite big companies. The individual fields, though, they may be small. So what these companies aim to get out of this project is that they get better advice for pests and diseases so that they can prepare for that, but also to prepare for climate change. So there is a kind of general interest because everyone has to do that. But at this point, what dominates, and understandably so, if I were a wine grower, I would do the same thing. I've invested in this, so the data is not for everyone. It is just for me to have my benefit. So, and as Lionel says, when you operate on a bigger scale, but then you would have something like Wine Growers United in Europe, then I think there's a mechanism to make this work and to share the data, but that would ask for an initiative at quite another level. So at this point, it is just, well, straight the business, like how can I benefit most from what is invested in? So yeah, thanks.
Yeah, it's a long journey, but yeah, we should achieve this for the benefit of everyone. Okay, Andrea, sorry, I almost forgot you. Do you have a question from the online audience?
Yes, we have a question whether using drone capabilities we can reach or not similar conclusions than those obtained at the pixel scale of S2 for getting more easily management recommendations, with the latter given the current high temporal resolution still fully unexplored. In other words, drones can serve to train large-scale model applications with S2 in the field of, for example, viticulture, when we know the spectral behavior at the higher scale with drones. Or do we need to move the satellite industry towards higher resolution sensors?
The satellite data, of course, is the most scalable tool that we have because it's worldwide. So, of course, if we can reach a similar resolution, a similar drone resolution with satellites, of course, it would be the best solution for everyone. Maybe even a paid service for this kind of resolution from satellite, because as is our experience in viticulture, the drone flights are very limited by the weather. That is maybe just a sunny day, but with a strong wind. And it's not always, it's something that people need to go on purpose on field to collect data. So of course, having the same resolution, a similar resolution from satellite could be the best option. And the result that we have found from drone is quite. I mean, we showed that it's quite different from the result from Sentinel-2 because it considered just the rows instead of the whole areas, the whole land with the crop.
I wanted to add that I think we are far to achieving a sub-meter resolution to optical satellites. So in drones to this day have a great advantage over satellites. The other advantage of using drones is that, for example, Sentinel-2 acquisitions are basically useless on vineyards when there are clouds. But our segmentation model of the rows works even when it is cloudy, and because it is very robust to different to visual heterogeneity in vineyard imagery. So this is another big advantage of drones over satellite data.
Yeah, we have. Yes.
Just to probably add to that debate that's going around, the satellite image providers probably need to increase their resolution. And this is happening over time as we see the technology improve. So that will happen. There is sub-level satellite available, but it's military. It'll never be commercial in that regard. We have to understand potentially with satellite imagery and drones, there's not one that is better than the other, that it needs to be used together in a supportive way. And that's how they complement each other. So it's just a different level of platform remote sensing, let's just say, but one is not better than the other, but together they can actually provide you a very good solution.
Yeah, we totally agree. Yeah, they are not an alternative. They must be used as a additional data. Okay. I guess we can conclude. So thank you everyone for being here. It was a pleasure for us to present you vitigeos, and hope to speak to you one-to-one during the lunch. Thank you.